In this video, we will learn how to find the equation of a straight line. Let us recap. If we are given an equation like this, y equals to 2x plus 4, how can we draw it on a graph? First, we need to find three sets of x and y values from the equation. We always use a table to show the values of x and y. Here, we have chosen three values of x. They are -1, 0, and 1. Let's find the corresponding values of y. When x is equal to -1, y is equal to 2. Because when you substitute -1 into the equation, we have 2 times -1 plus 4, which gives us 2. Now, we plot the point -1, 2 on the graph. Next, when x is equal to 0, it is easy to see that the corresponding y value is 4. Let us plot this point, 0, 4, on the graph. Finally, when x is equal to 1, the corresponding value of y is 6. So, we plot the point 1, 6 on the graph. Now that we have plotted all the 3 points, we can draw a straight line that passes through all the 3 points. This straight line represents the equation y equals 2x plus 4. Now, let us see how the graph and the equation of the line y equals 2x plus 4 are related. In particular, how are the values of 2 and 4 related to the graph? To see the relationship, let us first find the gradient of the straight line. To find the gradient, we can drop a vertical line down from the point 1, 6 and draw a horizontal line from -1, 2 until both lines meet at a right angle. The gradient is given by the rise over the run, which is y2 minus y1 over x2 minus x1. This will give us 6 minus 2 over 1 minus -1. Therefore, the gradient is equal to 4 divided by 2, which equals 2. Now, let us first see how the value of 2 is related to the graph. Can you see that the gradient 2 is reflected as the coefficient of x? The coefficient of x represents the gradient of the graph. Now, let us look at the graph again and see how the value of 4 is related to the graph. Can you see that the line cuts the y-axis at 4? We can also say the y-intercept is 4. So, if the gradient of a line is m and the y-intercept is c, the equation of a line can be represented as y equals mx plus c. In general, the equation of a straight line, that is y equals to mx plus c, is known as the gradient-intercept form. The coefficient of x is denoted as m, and this represents the gradient of a straight line graph. The constant, which is denoted as c, represents the y-intercept of the straight line graph. And finally, what do the x and y variables represent? The x and y represent the coordinates of any point on a straight line. One important point to note is that the coefficient of y must be +1. And this condition has to be satisfied. Let us see how we can apply what we have just learnt. In this example, we are asked to find the gradient and the y-intercept of the straight line graph y equals to 2x minus 7. We will now use the gradient-intercept form, that is y equals to mx plus c, to help us find the gradient and the y-intercept. When we compare y equals mx plus c with y equals to 2x minus 7, we see that the straight line graph has a coefficient of +1. This satisfies the condition for the gradient-intercept form. Now, let us find the gradient. Look at the coefficient of x in the equation of the straight line. We can see that it is 2. Hence, the gradient of the line, which is denoted by m, is 2. Now, let us find the y-intercept of the graph. Since the constant in the linear equation is -7, the y-intercept, which is denoted by c, is negative 7. Now, it is always good practice to reflect on our answer. In this case, how would the graph actually look like? When we sketch the graph, we usually label the y-intercept first. Since the y-intercept is negative 7, we mark the point and label negative 7 on the y-axis. And since the gradient is positive 2, this tells us that the graph must be increasing from left to right, and it has to pass through the y-intercept at negative 7. In this second example, we are asked to find the gradient and the y-intercept of the straight line graph y equals to negative 3x plus 5. Again, we will apply the gradient-intercept form, that is, y equals to mx plus c, to help us find the gradient and the y-intercept. When we compare y equals mx plus c with y equals to negative 3x plus 5, we can see that the straight line graph has a coefficient of positive 1. This satisfies the condition for the gradient-intercept form. Now, let us find the gradient. If we look at the coefficient of x in the equation of the straight line, we can see that it is negative 3. Hence, the gradient, which is denoted by m, is negative 3. Now, let us find the y-intercept of the graph. Since the constant in the straight line equation is 5, the y-intercept, which is denoted by c, is 5. Now, let us sketch the graph to see how it actually looks like. We will first label the y-intercept. Since the y-intercept is 5, we label 5 on the y-axis. And since the gradient is negative 3, this tells us that the graph must be decreasing from left to right, and it has to pass through the y-intercept at 5. Now, let us take a look at the last example. What is the gradient and y-intercept of the straight line graph 3x plus 2y equals 6? Again, the first question we must ask is whether the equation is in the gradient-intercept form. In this case, you can see that the coefficient of y is 2. Hence, we will need to rewrite the equation such that y is the subject of the equation. We will first subtract 3x on both sides of the equation. This gives us 2y equals to negative 3x plus 6. Since the goal is to have the coefficient of y as positive 1, we will divide the equation by 2 throughout. Hence, we get y equals to negative 3 over 2x plus 3. Now, the straight line equation has a coefficient of y as positive 1, and it is in the gradient-intercept form. Hence, we can now compare y equals mx plus c to y equals negative 3 over 2x plus 3. Next, let us find the gradient of the straight line graph by looking at the coefficient of x. We can see that the coefficient of x is negative 3 over 2. Therefore, the gradient, which is denoted by m, is negative 3 over 2. Now, let us find the y-intercept of the graph. Since the constant in the linear equation is 3, the y-intercept, which is denoted by c, is 3.